Well, I have a wonderful electronic invention I want you to see. It looks something like this.
Hey, what's up everybody? This is Titans of CNC, and I'm here at EMO 2019 at the DMG Mori building, and I'm here with my man, Matthias, the genius behind additive and subtractive manufacturing. What's up, Matthias? How are you doing?
Oh, I'm doing great. And it's an amazing show. We have an entire hall kept with technology, and I'm so happy to have you here in our booth.
So good. And the machine, look at this machine. It's like additive and subtractive. It's a beast of a machine, right? Can you talk about it a little bit?
Sure. It's a combination of 3D printing of additive plus the subtractive, the CNC. So we print up layer by layer, additively build up parts, and do the final milling within the same clamping situation, and it's gone, ready for build-in. You know, it's not only additive, it's making use of multi-material application. So the part what we built here, it's a dual channel connector, stainless steel and aluminum copper in combination. We build it up, do all the milling, gone, ready.
And you guys do a lot of like additive also, not just the combination, but you guys make some crazy parts. I saw some keys over there.
Oh yes, that's another manufacturing method for the 3D printing. Come over, I'll show you.
Awesome.
We're doing the powder bed business, selective laser melting, SLM. Look inside that beauty chamber. We are printing here keys, and the process works like a kind of a micro welding. So we have coming from the top through an optical arrangement, the lasers coming through that, shooting on the powder bed and selectively melting layer by layer, and one layer could be 50 microns, and this happens hundreds of times until the part is finished. The build plate is going layer by layer, so saying 50 microns by 50 microns, getting down, and the next powder layer is coming on top. The process restarts again, selectively melting the powder, bringing a new layer in, and the build plate, by the exact amount of the layer of the part size, is going down. But come over and I show you the application. This is an impossible key. The difference is inside that key. The part you cannot see, right? You cannot copy the key. And this is a perfect example of what additive can do for you in your standard life. You cannot see anything from the outside. But guess what happened? You can lock and unlock. Now I lose a second one and try also to unlock, and it's not working. So the beauty is the simplicity of that key. To give you another example, what's also possible for tooling industry, it's a PCD milling head. So we print on top of an HSK A63 this structure. You see a lot of holes inside, and here the cutting, and it's out of stainless steel. But the beauty is inside, what you cannot see. That really shows you the beauty of the process again. So you can print the cooling channels to exact angle where you need the cooling. So for your heat affected zone, you get perfect cooling. And also see the inner structure, it's a lightweight structure. So less weight rotating, that gives you less force you need to rotate. And this is a standard part we can also purchase out of a catalog. And he's printing this structure in our machines. Also another example, this is again tool steel, what we see here. This is from our customer Siemens. I rotate the part. It's a burner tip. It looks like a bionically printed heart, but it's used for a burner tip to make use of the power that's typically just gone and wasted. And through that inner structure, the power is reused again. And here you can see what it's possible with 3D printing. You can really bionically build up every kind of inner structure you can think of. Again, this procedure, this manufacturing now opens up a new field of design that gives you a new freedom in design. Be creative, think in corn sizes, and you can bionically print parts. Titan, here's another example of the hybrid side of the additive plus subtractive. For example, look at this. It's a propeller out of stainless steel, right? So we print it up and do in one clamping situation, do all the milling afterwards. That you get these beauty surfaces all over, right?
If you had to mill all of that, that's a crazy amount of time.
It is.
Yep. Yeah, beautiful parts. So all of these were actually printed and milled, sort of hybrid.
Exactly.
Right?
That valve housing here. There was a damage in field operations, so we additively add the material here, layer by layer, and then with the same clamping situation, do all the milling afterwards, and the part can be reused again.
3D printed, all inside, making parts that you could never make in the past, taking technology to a whole nother level. Matthias, thank you so much for your time.
Titan, good to have you here.